Today, we're going to talk about the difference between mass and weight. They are not the same thing. Mass and weight describe two different things, which are related to each other, but they are different. Your mass is basically the amount of matter that you're made up of, the number of atoms, how heavy those atoms are. That is measured in kilograms. So if each one of these little balls here is 1 kilogram, we have altogether here 6 kilograms. And that would be our mass. That's different than our weight. Your weight is a force. It is the force of gravity on your mass. So it's the earth pulling down on your mass. And it's measured in newtons because all forces are measured in newtons. And so our weight, to find our weight, we take our mass, and on Earth we multiply by 9.8, which is the acceleration due to gravity on Earth. So we would take our 6 kilograms and multiply by our 9.8 meters per second squared, and that would give us, comes out to 58.8 newtons. A newton is a kilogram. All we do is we take our kilograms and we multiply by our meters per second squared. So a newton is a kilogram meter per second squared, which is really ugly, so we rename it the newton. Okay, so let's say we, instead of having those 6 kilograms on the Earth, we took them to the moon. Guess what? The mass on the moon would be the same. So it would still be 6 kilograms on the moon. Still 6 kilograms. But now our weight is going to change. So I'm still 6 kilograms. I'm still made out of the same number of atoms. I haven't gained or lost atoms when I went to the moon. But the acceleration due to gravity on the moon is 1/6 of what it is on Earth, so it's about 1.6 meters per second squared. So my weight on the moon is now my 6 kilograms times the acceleration due to gravity on the moon, which is different than it is on the Earth, so it comes out to a different number. It comes out to 9.6 newtons. So my mass is the same. That's very important. My mass is the same. So get that. Make that a big bullet. Your mass is the same everywhere. But your weight changes because your acceleration due to gravity changes depending on where you are. So even if I was out in outer space, removed from all gravity, my mass would still be 6 kilograms. But my weight then, which is a force, would be 0 newtons because there's no gravitational attraction on me. And that's the difference between mass and weight. And get it straight because it's going to come up a jillion times during this course.